Hi, everyone. Thanks for joining us at Ignite. How are you guys? Awesome. Are you ready for bracing yourself to go through something like a dozen demos? Yeah. OK, cool. Well, my name is Olivier. I'm part of the Azure IoT team. This is Arjmand.
Hi, I'm part of the Azure IoT team as well, and together we are going to take you through a bunch of demos, lots of technology that we have here, but we are going to make it easy so that you can really go back and start playing with it.
Awesome. So I hope people will start coming. They gave us a very big room. If you guys at the far end want to come closer, it's not going to be any different, but I won't feel like I'm speaking to only a few people. So we've been talking about how we are simplifying IoT. If you've not heard that message, then we've not been shouting it loud enough. IoT is not easy. Who's in the business of doing some IoT applications today? OK, so like maybe a quarter of you guys. So that session is going to be about introducing you to IoT in a way, but also for those who are already in the IoT business, understanding what's new that will make your life easier. Hopefully, from time to time, we'll hit a demo that you will say, holy cow, I had to do that by hand. Thank you, Microsoft. And sometimes you'll come at the end and say, Olivier, no, doesn't work for me. So we want to have your feedback at the same time. So don't hesitate to try and ask questions. I think we have different microphones here and there. We'll try and save some time at the end if I speak fast enough to go through the demos. But what we're going to try and do is illustrate some of the aspects of how we're making IoT application development seamless, how we make it the operation of IoT apps also easier and seamless. The security is a key topic. Security is a core part of the IoT story end-to-end. And so Arjmand is our resident expert within the Azure IoT team, keeping us honest and making sure that we don't go rogue or whatnot. And he will actually talk about securing an IT application. We'll have some demo, and we'll dig deeper into what does that mean.
And the point here is that we always think of security as an end-to-end thing. It is the device security, connection, cloud, all of it together. And I think when you think like that, that is your most secure deployment of IoT that is possible. And we're going to talk about it today.
Totally. And then another aspect of IoT, it allows to bring the intelligence of the cloud to the edge. We'll talk a bit about that. We'll demo some stuff around Azure IoT Edge, running AI at the edge, but also how to secure your IP when you put that IP that you put years development and research into onto IoT devices which are exposed physically to attacks. So we'll talk a bit about that as well. So let's look at a typical IoT application. What I want to point out here is what are the key things here and there that are hard to do in IoT today. And not just today, it's been for a long time. When you think about an IoT application like this one, you have devices they want to connect, or you want to connect them to harness all the data that they can produce to be able to extract insights and then take action. Right? That's the basics of what IoT applications are all about. The first problem that you're going to face in this kind of scenarios is to connect the devices. They might be connecting on different types of networks. You might need to go through a gateway. You're behind a firewall. The device might not be IP-based, so you need to actually translate protocols. The other problem is all these devices coming from different manufacturers in different industries, they talk different languages. They might be sending the data optimized for bandwidth, so it's encrypted, or just a few bytes versus a full JSON file that really describes everything which is in the payload of these devices. The second aspect is the gateways. So the gateway itself is an instrument that will allow to connect devices, translate the protocols, and eventually now bring the intelligence of the cloud down to the edge. But you need to be able to manage, monitor the health, configure these gateways remotely. Connectivity is a problem we will not really talk about today, but it's key, and you need to think about it. That infrastructure at the edge will need to connect to the cloud if you want to gather the data and eventually extract the insights you need. So connectivity for these devices can be a satellite connection, can be GSM connection, can be different types of things. And so we're working with different partners to bring solutions to connect these kind of devices infrastructures to Azure. I'm not going to dive into that, but definitely something to keep in mind when you're designing an architecture of an IT application. Then the other thing is the cloud hub. How do you provision, securely identify, authenticate these devices, make sure they are who they say they are, and then manage them from up there. Right? Manage the life cycle, update the firmwares, update the software, change the configuration. You need to have something in the cloud that actually will be your hub for these devices and for the apps to connect to it. You will need to think about how you hook up all that data that flows into the cloud into processing algorithms and workloads. And we'll talk a bit about that, show some examples how we are making that flow a bit simpler in Azure. You will need to connect to business applications. Once you have interesting data about a device, what do you do with it? That device is about to fail tomorrow. Yay! No, now I need to start a workflow in my business app for having a maintenance ticket created, having someone going on site fixing the problem before it happens. So you need to easily integrate into a slew of different types of application in the business world from your IoT world. And then you will need to monitor what's going on, maps, time series insights and things like that, right? So this is the view of an IoT application end-to-end. One key topic, and this is why Arjman is here, is to talk to us about the end-to-end security. How do you make sure all that is safe?
Thank you, Olivier. So, yes, it's the same picture, and I'm going to talk about security end-to-end on the same architecture. So, we think a lot about threats for IoT deployments. And the good thing here is that many of the threats we have been thinking of in the IT world for years and years are still applicable. But then with IoT, there are many new threats which are different. And the difference really comes about from really two things. One, these are physical devices. And hence, the attacks can be very different. And the consequences of those attacks can be very different. You can take down power grids. You can take down things that people have in their homes. You can use those very same things to attack the internet. And you can bring down the whole internet. So you have that scale, you have that distributed nature of deployments, and you have access to those if they're not secure. So we think a lot about the threat model, where it all starts, and then we start designing. So I'm going to point out a few of the prominent threats just for examples. There are many more, and we have published quite a lot of material on how to actually do your threat modeling for IoT deployments end-to-end. But I'm going to talk just about a few of those. The first one, of course, is how do you trust your device for its identity? Right? Now, typically, IoT devices do not have an interactive user attached to it. There is no admin, typically. There is no user who actually signs in and then takes over the device. An IoT device intrinsically has its own identity. And then based on that identity, it connects to the cloud. And so built into that whole mechanism has to a way to attest that identity, make sure that that intrinsic identity is part of the device. And we're going to actually demonstrate a few things today. Can you update these devices? Now, IoT devices are deployed out there, and we're talking about scale. And when we talk about scale, we talk about millions of devices out there. So you want to keep all their firmwares, all their the software stack on it, operating systems, all up to date. And when you have a security bug that you found, you want to go back and update those devices. So can you do that securely? And can somebody take over that mechanism of updating and make those or own those devices, a malicious actor? So that's something we think of. Again, we'll show you a few things we have here. And this tampering thing is important because remember, IoT devices are deployed out there. They are deployed in a mall, on the side of the road, in a car, and the attacker can actually physically access the device, steal the keys, do something bad, or put some code on it, and you would never know what happened. So how do you protect against that? And this is something that we have thought a lot about. We also think about the workloads that run on top of these devices. And here I'm saying gateways, but that is for any IoT device, gateway, edge, or otherwise. How do you actually know if the workload running on that device is the workload you want to run over there? Right? So how do you sign? How do you attest? At runtime, how do you make sure that this is the right workload, and so on? Can you detect if the right device is connecting to your gateway? Because remember, these gateways could be out there, outside. And so anybody can come in and start connecting or physically connect a wire to it and start connecting a device. Now, can you detect that? Can you detect when that kind of intrusion is physically happening there? And then how can you alert that? We have a demo for that today. Can someone see the data? Obviously, this is something when you have a network, you have devices sending out a ton of data to the cloud or cloud sending commands to devices. You want to make sure that that data is encrypted, secured, and is not visible to other people. Another attack here, can you trust the admins who are actually running your operations? And how do you make sure that you can detect if an admin's standard behavior, known behavior changes? Right? Again, we have something to show today, and we can actually detect a bunch of those intrusions. Can you monitor all your integration points? So a typical IoT application in the cloud or on the edge has a bunch of integration points. You're getting data, you're getting commands in, you're using the data for analytics, you're getting some insights, you're running a business process based on the data. So all these integration points, you want to be sure if they are the right integration points, if they are protected, they have the right authentication with each other. So something that is important, because that's another attack vector. And with the Azure IoT and with Microsoft's IoT deployments, we ensure that, and we provide you with features which allow you to do that. So now, I think about time we jump into demos. And Olivier, over to you.
Thanks,
I know, you need to wear.
Thanks. No, demos are not dirty, but still, sometimes you need to be prepared for that. So let's go into some of the demos. Let's start with how do you connect and communicate with devices in the world of Azure IoT. It all starts in the Azure portal. There's a cool tool, and I'm going to point at some interesting tools wherever you are, whether you are more of a web browser or a IDE guy or a command line guy. I'm going to point to various tools you can leverage and use to do similar things, if not the exact same ones. And the reason why we're providing different options is because we know that you, enterprise developers and IT pros, have your favorite setup on your machine. We don't want to ruin that or force you to go somewhere else. Another aspect of that is we know embedded developers are very often constrained to specific Linux versions, or they have to work with tool chains that require some specific environment. So the more options we offer in terms of development tools is not to confuse you, it's really to help you get into the IoT business. So the Azure portal is great. There's a new Windows app called the Portal, the Azure app. And so it's pretty cool because it isolates the Azure portal view from all the rest of the web. So if you want to focus on Azure, you can definitely just find this app in the store and just use it. To create an IoT hub, which is our hub in the cloud for devices, that's your starting point. Azure IoT Hub is, if you want to go grassroots, and I'll talk about other solutions, but if you want to go down there, create an IoT hub in your subscription, and you can get going. I already created one of them in the portal earlier on. Another option is to use the Azure CLI. There's an IoT extension for that. So you can leverage the Azure IoT extension in the CLI, which is all command line, and you're able then to play around with IoT Edge, IoT Hub, the digital twins that is coming soon, the plug-and-play interfaces as well that we'll talk about. So once you created an IoT hub, what you will do is start monitoring what's going on. You can continue using the CLI, but I have another very fun tool to leverage and use. It's called the Azure IoT Explorer. That's a tool we recently revamped and totally changed that allows you to monitor several IoT hubs and configure them and work with them. And that's for a developer to interact with his IoT hub. So here I have an IoT hub. I created a device identity in there, and that's the starting point for a device to authenticate to IoT Hub. We'll talk about the various options in a minute with Arjman in terms of how you will authenticate. So that device here, for now, I don't know much about it. So what I'm going to show you is what's in the code of that little device. This is a Python piece of code here. We have an SDK for Python. This is open source. We have a C SDK, a C# SDK, a Java SDK, a .NET SDK. So we pretty much have a good coverage of all the SDK. The C SDK is NC99, is something that is highly portable and runs on real-time OSs, and we really recommend you to go check out if you're in the business of creating applications for devices. So this little Python code just doesn't do much. It actually connects to IoT Hub. It has, you'll see the Raspberry Pi Zero, which is running that. I'll show you in a second. It has a set of LEDs that I can work with. And then after connecting, I have a little function that allows me to send messages. Another one that will interact with IoT Hub through what we call the device twin. And last but not least, the direct methods. I'm going to show you all the 3 ways of communicating mainly with a device. So the first one being telemetry. The telemetry from the device perspective is about sending a piece of data. So you create a payload, and then you basically just send that payload onto the SDK for it to actually send it over. So actually, if I go up to that send message, I should see the actual code for that. And I did pass it. Did I send test message, message index, and then where is my message load? Yeah, there you go. So that's the command, send message for sending a payload. The payload, we don't care what it is. I'm going to show what that looks like. So for that, I might need you, Arjman. So to show the device, the first thing I'm going to do is switch to that guy here. So this is the view of the devices. We're going to play with that little guy here. But because it's always hard, oh, leave it there, leave it there. What you're going to do is you're going to hold the phone. We're doing a trick, magic trick here.
I don't know what this is, so we're going to try.
Okay. So you want to point to that device, stay there,
cool.
And we're going to see the device down there. What we're going to see as well is my command line where I can interact with my device, and what we're going to see as well is the tool to allow me to monitor what's going on. So I'm going to monitor the telemetry for that device. I'm going to pick one of the consumer groups, which is debug.
This is not coming.
Yeah, that's good. Start. Oh, I'm not showing my screen. Thank you, Arjman. That's why I have an assistant.
Yep.
Today.
There we go.
He knows what I'm not doing right. So let me actually start that piece of code. What I showed you in the VS Code interface is what's going to run here. And I'm going to start my IoT Hub client. So this little application will get started. We'll connect to Azure IoT. It actually, you can actually, yeah, there you go. You could see it was connecting for a second. Arjman is discovering Android. That's okay. I'm going to send messages. I'm going to send a batch of these messages. And you'll see that I'm sending these JSON messages. They're arriving in the cloud. I can monitor that using the IoT Explorer tool. And you see I started blinking some LEDs down there. So that's the first step, just raw messages sent up to the cloud in these packages. And you can actually compress that if at the other hand you're able to decompress on your own after IoT Hub. The other way of communicating is using the device twin. Device twin is a way to synchronize a state between a device and the cloud. And it's actually a JSON file. The JSON file will indicate a set of properties that are desired from the cloud to implement an action, and the ones that are reported from the device, right? So here in the device twins, I have a set of things to do. So let me actually kill that thing. I'll go back to that so that it turns the LEDs off, and we should have that. Oh, actually, if I were able to, right, that would work better. There you go. I'll go back to that method in a second, just like Jinx did. So desired properties is the way I'm going to say, hey, device, I want that specific state to be changed to something else. On the device, I have a routine that actually is monitoring for messages coming from the cloud. We're using MQTT to exchange messages under the hoods. But here, let's say I want to turn a LED on, and I want to blink it. So eventually here, I prepared a set of desired properties for LED 1, 3, and 5 to start blinking in different colors. So I can actually just then refresh on that, and actually need to change the numbers because otherwise it's not a change. Let me actually do that. So what's going on is that we have a system that will monitor which of these entries have changed versus the ones that actually have not changed. And that way the device knows, what are the new desired properties are to be updated. And so when I send that, the device itself will receive the twin and will be able to change. I didn't save, my bad. Let me just do one then. I'm really bad. Save. There you go. And you can see here on my camera, never easy.
There we go.
Why would it be easy? Yeah,
Yep.
you can see that
the change has come back.
Blinking after me changing the device twins here. And there's also a set of reported properties. So the device is actually permanently reporting when there's a change, the status of the various LEDs and what they're doing, right? The direct method is a different way of interacting. It's a synchronous way to interact with the device. The twin is fabulous when you want to interact with a device that eventually is not even connected. You can say, when you get online, I want your status to be that. The direct method is something that is, I'm going to send you a message, I want you to respond in that amount of time, right? So for the direct methods, the principle is pretty straightforward. You need a name, and you need to specify the name and then the various parameters to that. So here I have a direct methods listener, and that thing will check the content of that message that is received from IoT Hub. We'll say, hey, what is your name for the method? And then what are the parameters, if any? And I have one called turn LEDs off, another one which is called scroll LEDs. And while you're preparing your project for Christmas lights, eventually you want to start looking into that, scroll LEDs. I need to put a timeout for the connection in case the device is not online. The method cannot go out. The user needs to know. It's synchronous again, right? And so I'm going to say invoke method. It's going to send a message to the device. The device instantly will start scrolling the LEDs. Pretty cool, right? So this is all good. We're able to communicate with the device, right? So now the fun thing starts, because I have this little device. Let me actually turn the LEDs off again. It doesn't matter much. Actually, I'm going to leave it there. It doesn't matter. What I'm going to do next is I'm going to connect this IoT Hub baby to something else. I want to trigger an action. I want to have something happen when a message is arriving in Azure IoT Hub. So if I look at my IoT Hub, there's different ways we can do that. The messages are ingested and stay for, I think it's, how long do they stay in IoT Hub? Is it 1 day?
Yeah.
You have 1 day retention policy by default in IoT Hub.
Which you can change.
Which you can change and adapt. And then what you can do is you can configure what we call the endpoints for that IoT Hub. There's a default one, which is an Event Hub endpoint, but you can also define other ones. So if you look at the routing parameters into the IoT Hub blade, into the portal, you can do that once again over CLI and other things. You have different types of endpoints you can create. You will create additional endpoints to IoT Hub for data to flow in there. And then you will actually create rules for sending that data into the various endpoints. You can say, if that message is an alert, I'm going to send to that specific endpoint. If it is not, then I'm going to send to storage, for example, for long-time storage. You can also enrich the messages. Maybe the devices don't have all the information. You place the specific device in a room. You know in the back end this device has been placed in that room. The device itself doesn't know where he is. It has an identity. But on the back end, in your device twin, you have a set of what we call tags that allow you to categorize the devices to enrich the content for the device. So for each message that comes in, you can enrich it with data coming from outside or from the device twin and say, that piece of telemetry data, not only is that device, number one, but it's also, sitting in that room. And so then in your back-end systems, you can now leverage more data and reach by IoT Hub. What I want to do, though, is show you another types of integration. So if I go back to home here, I'm going to look at my resource groups. I have a demo resource group. You see how fast the application is versus the browser? Just like, I don't have any friends in that team, but I like the job they've been doing here. So this is a Logic app. Logic app is a way for, if you don't know, creating flow in the cloud between different applications, whether they are first-party Microsoft or other ones. You have connectors, and you can very easily construct these flows. And here the flow I have consists in being triggered by Event Grid. The good news is that IoT Hub now fully integrates into Event Grid. So now you can use the POP-SOP infrastructure of Azure Event Grid with IoT scenarios. And here I selected from my subscription an IoT Hub, and I say that for each of the devices that come in, and what I'm doing is I'm checking a condition here, which is in the body. I want to see if there is the field alert that is set to 1, and if that's the case, or to yes, and if that's the case, I'm going to post a tweet. And if that's not the case, I'm going to just send that data into a blob storage, right? So let's go back to our device. Let's bring up Twitter. Wouldn't be funny, right? This is the Azure IoT demo Twitter. Don't follow it. It's just for demos. People are starting to follow that. That's okay. But that's not very useful.
They want to know what you're up to, right?
Yes, exactly. I think that's what they are up. Yeah. They're looking before. So actually, let me turn that on or off. There you go. Turn LEDs off. I want to stop this guy here. receive the command. And what I'm going to send an alert from the device. This is just a telemetry message that has a field alert set to yes somewhere in there, right? And I'm sending temperature in there. And because that field has alert in there, it should have been sent to that logic apps through event grid that called Twitter because it was an alert message. And here I see my Twitter that's been actually posted 10 seconds ago. And I promise, it's not because he has the phone in the hands that that's what happened. It's not.
No, I'm not messing up. I'm not messing things up.
Okay, so pretty straightforward all the way up to here. We're able to connect the device. We're able to communicate in various ways with that device. We're able from IoT Hub to send data to somewhere else. But it seems to be pretty hard still, right? So let's try and simplify all of that a bit more.
And while we do that, or before we do that, this whole communication that happened between the device, the cloud, and all of this, and from this computer here, was encrypted using TLS sessions. It was sent up with authentication. It was authenticated, access control. So there's a bunch of underlying infrastructure for security that was being accessed here, that was being used here. And that's important to remember that we have abstracted that out, but it's not that it's not there. It's all there, and it's happening.
Awesome. So Azure IoT Central, think of it as the solution platform that comes on top of IoT Hub. IoT Hub is the engine. IoT Central is the car, right? What you want to use is a car. As a matter of fact, not everyone wants to use the same car. I just made up that analogy on the spot.
Yeah,
I like that one, actually. And so if you want a truck or a van for transporting goods, it's not the same thing as having a truck actually for transporting your kids to sport events, whatever. So like customers want different types of trucks. IoT Central is the brand for like several types of trucks that you will want and need. IoT Central actually is a website that you can create your account into, and with an Azure subscription, you're able to create apps. And when I say apps, it's really about operational apps. So if I want to create a new app into IoT Central, let me actually go back to the landing page. Landing page is apps.azure-iotcentral.com. And this is where you're going to go. The idea with IoT Central, and you certainly heard that from Sam George in his session, I'm not going to go through that again. The idea really in general is to build apps with IoT Central. Use IoT Central as your gateway for devices, as well as your OT interface for your operators. And here, if I want to create a new app, what I would have to do is, since last week, what you're able to do is to start from a preset, pre-hashed template. And you can go with retail, energy, government, healthcare. Let me actually pick one in energy, and we have some vanilla templates. One is like solar panel monitoring. So let me create that app from here. It has a default name, doesn't matter. Microsoft repository, I'm going to pick one of the 200 subscriptions that I can access to because I work for Microsoft. I hear they're jealous, just like, I just have one.
But you forget which one to use, so too many here.
No, totally, I don't forget. I don't forget, for damas. And here the application is being populated into my browser. And yeah, you've seen there's a little bug. I don't want to put the IoT Central team on the spot, but the refresh here, it was required. And here I have an application that is not the final application. That's where I'm going to start my work, and I'm going to start customizing that application for my needs, right? And it goes all the way through, let's say I'm going to navigate through my devices dashboard. I have this kind of device here. That one actually gives me properties about the device. I have a panel. Did you see how fast, by the way, everything has been deployed? It's actually there. It says missing data because the simulator is actually powered up in the back. While we are starting using that, we have all the infrastructure for the application is being deployed. And so now I can start interacting with that device from here without having done anything. What I can do is not just look at what's going on. I can also go play around with the what we call the device templates, which describe what the device's capabilities are, what the various views are. So here, this type of device is providing a certain number of what we call interfaces and a certain number of views. And the views are the graphics views that you were seeing earlier on. And from here on, I would be able to change things and say, hey, let me change the type of view here. Let me change the visualization. Let me add another one and so forth. Another thing you can do is you can start managing the application, define new rules new roles, sorry, and assign the roles to various users and vice versa. You can also monitor your billing and so forth. One thing which is interesting, we have this little entry here which is called access tokens. For developers, this is a sign. We are opening up APIs for IoT Central, meaning you will be able to integrate IoT Central within a broader application. You have a token from an app, you use the APIs with that token, you have access with a certain amount of permissions to modify the application, to work with the devices in that application, to create rules that will be implemented by IoT Central as well. Another very interesting thing is the continuous export. So you are able now to export the data from the devices to another system, to another application or service. And right now we support blob storage, event hubs, and service bus. This is the beginning. We're going to have more to that. Another one is the rules. I'm going to show you that through a demo. So here it's all good. I have this application, but now how do I connect these devices? And so if I had created an application from scratch, like this one, that's what I was talking about, the little refresh bug here. And here I have an application that is not fully empty. It doesn't have any devices. It has a device model. But let's say I want to connect a device to that guy here. What I'm going to do first is I'm going to go to that device connection section. And here, Arjun, can you tell us a bit about how IoT Central will work to authenticate devices?
Yeah, so there are a bunch of options here, and Azure IoT supports SaaS tokens. That is a very basic one, as well as X509 certificates. So with these two options, we of course have some opinion on what kind of hardware you use. Hardware-based security is important because that ensures that whatever secrets you store on the device are in hardware and cannot be tampered with. So while you have these options, underneath, again, there is infrastructure, there are SDKs, there is APIs that we provide so that you can store these secrets in hardware and then get access to those whenever you need.
Awesome. And so what we're seeing here in that section is what we call a scope ID, which is that unique identifier for the IoT Central application. And then we have an option of shared access signatures or certificates for both the regular devices and IoT Edge devices. We'll talk about the IoT Edge devices in a little. But when it comes to the certificates themselves, let's say I want to add, I have my own system that manages my devices authentication or certs provisioning. An example of that is Azure Sphere, right?
Yeah.
So Azure Sphere is a great example of that. Can you tell us?
Let's spend a few minutes on Azure Sphere. There was a session, I believe, yesterday. Galen Hunt, who manages that team, talked about the key ingredients of Azure Sphere and the business around it. So at the very core of things, Azure Sphere is an opinionated, our opinion, of what a highly secure IoT device should look like. It's silicon design, so we came up with the silicon design and we licensed that out to our partners who actually create that device. Now the core there is, just to simplify that conversation, there are 7 properties for highly secure devices. That actually is a paper which we published and looked that up. And these 7 properties define what that device functionally should do. For example, it should have a hardware-based root of trust. It should be able to update itself securely. You should be able to monitor it. And all of that you should be able to attest and you should be able to do it under secure environments. And so that device has a secure operating system. It has a security service which allows you to monitor that device, update that device, provide certificates, attest, and so on, all through that one place in Azure. So Azure Sphere, we have a bunch of partners who are actually working on providing those as actual devices, and then we provide the services for those. And yes, we are pointing it here. Here is a dev kit, which is based on Azure Sphere. It's sitting right over here, the silicon itself. And Olivier has booted it up, and it has Wi-Fi. It's connected up to the cloud, to this Wi-Fi router, and then to the cloud. And now we are going to do a few demos using that device.
There you go. So I connected while he was actually talking to check that Wi-Fi was working. So that's the big risk with this kind of demos because you all are on the Wi-Fi network, and so are we. And demo 1 that was not working. So primary key here, and we were talking about the authentication of devices using certs. In IoT Central, you will actually be able to set a root certificate that will be used for authenticating devices, right? So a device manufacturer eventually will provide you with that root cert for you to put into your app, right? And that's what we did here with the Azure Sphere security service. The Azure Sphere Security Service has a tenant for myself in there, and I was able to extract a root cert that I now injected into IoT Central, and I created from there the right thumbprint and so on, so that I could then and verify that cert, so that after that, any single device that is an Azure Sphere device connected to my tenant of Azure Sphere Security Service will be able to connect to my Azure IoT Central application in a very secure and safe way, right? Make sense? So now, I created an app plugged in that device. It connected to the internet. It went to the Azure Sphere Security Service, and then it went to the Azure IoT Central application. I've been putting on that device in the code the scope ID for my application, so that it knows which IoT Central application to go to, as well as that derived cert that is coming from that root cert has been onboarded onto IoT Central.
And while that was happening, in the background, Azure Sphere, because it connected and the cert was signed, it did an attestation of its firmware, and then it provided a attestation value to the cloud, and then the cloud said, yes, I actually trust this device, which was a measurement, an actual measurement on the device. And because now that device is trusted, we can proceed with the demo.
So now I have a device into IoT Central, but the application knows nothing about it, right? So the first step at this point with that kind of device is to actually create a new device template. I'm going to say it's an IoT device, and what I need to do here is manually describe what the device capabilities are, right? This is getting simpler, right? This is where we have more after. So here I'm going to say this is MT362, because you've noticed I have another one. And what I'm going to do in here is totally create everything from scratch. I'm going to create what we call an interface, and that interface will be a set of capabilities. The first one will be temperature, and that's going to be telemetry. And that's going to be a double that I'm expecting in that message, in that payload from the device itself. I could go on and define other things such as properties and commands that the device supports. To make it a bit simpler and faster, what I'm going to do is go back to the device. I already have, to the templates. I'm going to describe my changes. I have another one that I created a bit earlier on today that has temperature. There's a button press on both sides that actually simulates orientation for the device or whatnot. I created a little view there with temperature, with orientation and button press. My view could change format. I can say instead of being a line chart, could be a heat map, could be something else. I can really design that. If I had location from the device, I could add a map to locate that device into my application. So I have this device now that has been coming in. I have a device type, but you see the device is not showing up in there. What I'm going to do is I'm going to select the device that showed up and migrate it to this new model that I just created, right? So this is great because now, without having to code anything on my backend application, when I switch to that device, it has a view with a line chart for temperature. And it has actually, we did press on the button as well. I did cheat while Arjun was talking. And I can actually play around with the button, and it was going to actually show the various data that the device is sending. So you see, very easily with that code on my backend, I could create a device model and use it. But for devices that are more complex, that can take a long time. So we actually brought IoT Plug and Play. IoT Plug and Play is a part of Azure IoT that allows device manufacturers to create models for declaring devices in a format that we open sourced and we aim at driving to standard bodies. So a device will have a model that is declared in a format that is well known. The IoT application will be able to get that model, which is a JSON file at the end of the day, and understand what the device does. So if I wanted to add a new, in my application, device template, what I could do is whether import that JSON file or navigate through the catalog. And we have now plug-and-play certified devices already available on that catalog embedded into IoT Central. Let's say I want to add a device like, let's say this guy here, just like totally random. I'm going to pick that did I select? Yes. And I did say I want this kind of device template, and I'm going to add it into my application. Oh, interesting. That's what happens when you pick a random one. Let me go and pick another one.
Pick the right one.
Another random one.
And while he does that, if you see what is happening here, we started off with going down to the core tools. You had code, you had all the twins, you could edit it in an editor, there were tools to look at data. All that is still there if you are inclined to do that. There is, of course, infinite opportunities for customization in that environment. And then we switch to this environment where the experiences are curated, yes, but at the same time, very quickly you could get to that graph, right, of temperature and up, down, and so on. But at the same time, there is flexibility with PNP models and so on, where you could define is it temperature or pressure. And so we have maintained some flexibility, but at the same time made it very simple as only configuration where you can go in there. And now with PNP, you can actually do it with any device. Well, awesome. Most devices.
So now I imported that device type, which is now part of my application. So if I go back to my devices list, I can see there's this new device type. As a matter of fact, there's none, because I didn't add any device. So let me actually add a new one, like random device ID. Let me create a simulated one. Because we have a model that describes what the device capabilities are in terms of telemetry, commands, properties, I can very easily implement a simulator on top of the plug-and-play model. So as an IoT solution developer, I don't even need to have a device to test that my dashboard is looking good, that the devices can be manipulated or worked with. And here I have the simulator going on. And as soon as the data will start flowing in my time series insight instance and so on, I will be able to start interacting with that simulated device. Now, if I had the real device that came in, I'm going to create a new device identity for that other device. And I don't check the simulated part here. And on that new device I just created, what I'm going to do is I'm going to say I want to connect that real device to my application. And here I get all the information I need to provision the device with the right set of credentials. And here you see a scope ID, there's a device ID. I can pick the connection method. Do I want to go with certificates? Do I want to go with the SaaS token? And then here is the primary key I need to flash on my device. All of that can be extracted using APIs as well in bulk, so that way you can work with your device manufacturer and tell him, okay, your IoT device is plug-and-play certified. I want the batch you're sending to me to have that scope ID and that certs actually flashed in factory. So that way, when they come online, plug and play. Nothing to do. Actually, you notice that I imported the model myself using the catalog. But there's more. There's something even like better to do. So I'm going to actually hook up another device down there. So that other device, let me switch real quick. That little ESP32 device. This is powered by an Espressif chip, which is a Wi-Fi chip, very popular out there, and we have that dev kit that is out there. So I just connected that device. While it's actually doing its thing and trying to find a Wi-Fi and so on, what I'm going to do is I'm going to switch to Visual Studio. Is it where I want it to go? No, this is not where I want it to go. I want it to go to this view here with VS Code. And so that little device here is actually implementing all the code necessary to have these sensors that will actually be sending their data up to the cloud. And so it's like C code. It's like something bare bone, really embedded type of things. I'm using VS Code here. There is a compiler, which is a tool chain from Espressif that I'm using Makefiles and things like that, all in the back end. So this is really hardcore type of development for embedded. And in here, we have a set of resources we provided in the form of the C SDK for plug and play, for connecting with the device twin as well as the sensors on the other side. And in a nutshell, what you're seeing is that the device will register itself. And when it's going to do that, it's going to do that with a specific piece of information, which is its actual device model. So actually, need to remember where that device model is. It's in the main or in this guy. There you go. So the device will declare its capability model. It would say, I'm this kind of device. And we have a URN here that actually is using something you know well in terms of formats if you're a web developer, and basically uniquely identify the type of device it is. For the IoT application to be able to grab to grab, this model from the catalog automatically and populate the application without the user having to pick the right device. So the device came online, has the right credentials, and says, I am that type of device. For the IoT Central application, now to say, let me refresh that, if that device is coming online. I should see, Espressive 32 kit. And so that one actually imported the model automatically in the same application as the one you've seen earlier on, right? And we can see for the kit itself, it has a set of capabilities, it has information, and so on, right? So this is something that has been imported automatically. In my list of devices now, I will see this little guy here that has appeared. The device identity has been actually used by the device. It was pre-provisioned with that kind of information. It actually decided itself, I am that identity. Could have been my MAC address, could have been something that is in a TPM chip as a seed or whatnot. And when I go to that device now, I should start seeing data flowing because the device is connected like a few seconds ago, and I see the data flowing into my system right here, right? So pretty straightforward, plug, play. The application in the back end leveraging the plug and play power was able to populate the UI for that. So this is all great. So connecting and understanding devices is now way simpler, right? As soon as we have a collection of these IoT devices that are plug and play certified, we'll be in a very good place, I hope. So here's what we're going to do next. From IoT Central, I want to trigger flows somewhere else. I talked about the continuous exports to other systems. Let me talk about the rules. There's a very simple way for someone who's not a developer to create rules within IoT Central. And in there, I can create a new rule. And I'm going to call that, I'm going to apply that to my ESP32 kit type of device. So that way I can really define a certain number of things. I can implement filters. I can actually start filtering and say, I just want the alert to be triggered when, for a specific set of that, subsets, I would say, of that device type. What I'm going to look at is the ambient light. Let's actually check real quick. I want to check something before. So that's my device here. I want to check the values for ambient light because the demo is live. So the actual lighting I'm getting on that device might not always be the same. So if I look at the device itself, and I find the ambient light information, I see ambient light has been pretty high, and it's above 1,000. Don't. You're going to trigger my alert before my demo.
Okay.
Kids, seriously.
So I was just playing. By the way, it's fun to play around with these devices. If you haven't tried that, do try that. It's a lot of fun programming them and playing them with them.
It is. So that ambient light, when it goes below 500 lumens, I'm going to actually trigger an alert. In the preview version of IoT Central, the one that supports plug and play, we limited the number of triggers. In the regular IoT Central app, you can trigger way more things like logic apps and dynamics and Microsoft Flow and others. Here, I'm just going to do a little webhook. And that's going to be webhook 1. And I should have somewhere a little flow that actually will be triggered. Oh, sorry. It's no longer called flow. Remember what it's called? Like it's Power Automate? Yeah, something like that. Anyways, I've got a flow here that's pretty straightforward and simple. It's actually a webhook trigger that will trigger a webhook. I know. It's just for showing you what it is, right? So this little guy here is very simple. When it's triggered, it's going to actually send a post request to a service. And that service actually is from our friends from a company that actually is building that little type of device here, right? So it's Embrava. These guys are connected through IoT Hub, but here what I want to do is interact with their service in the back end. It's a room occupancy monitoring system, and through that little post, actually it will be able to set a new meeting in there. So let me actually do that, copy the trigger here, paste it here, done. And my alert is now saved, and next time the light goes below a certain level, I should have everything working. It's now that...
Fingers crossed, because there's a bunch of pieces here.
Yeah, a lot. And this guy actually will take a couple of seconds for having the ambient light to go below a certain level, and then it will go there. So leave it down there, and it will end up working. I'm fairly sure it will end up working. If it doesn't, then my bad. And that's because of you.
Oh, okay. It's all my fault now.
So you've seen how you can really rapidly integrate an IoT device. It actually plugs and plays itself into IoT Central application. What we can do next is actually jump into the security aspects of things, right? And then we have IoT Edge to talk about. But we want to talk security.
Quickly about that security monitoring. We talked about end-to-end security. We talked about hardening, hardware-based root of trust, identities, cert management, and so on. But also, you want to have some level of monitoring. You want to know if your whole deployment, this includes your little devices, your cloud, your gateway devices, what's going on there in terms of security. And then you want to know if bad things are happening there. So for that, we have this thing called ASC, Azure Security Center. There you go.
All right.
Yeah, it works. So Azure Security Center for IoT, which essentially is a service in the cloud, but we have extended it out to IoT devices as well. You can have agents on devices which will pick up that information and bring it to the cloud, and then you get alerting like this, like what you see up there, right? So, would you want to explain?
Yeah, I can run through real quick. So here I have the interesting thing also with Azure Security Center. For those who are not familiar with it, it basically, especially when it comes to IoT, it has two views. One is the IT view, what I like to call the IT view. You are responsible for monitoring and managing a set of Azure resources for your company. Right? And if you go to the portal to the Azure Security Service landing page, what you're going to get as a view is the one you're seeing right here, which is for the subscription I'm actually monitoring. I'm going to get all the information on that dashboard for all the resources, all of them, whichever app they belong to. And this is really useful because you have a very broad coverage of information. You're going to get recommendations that are actually generated, as Arjun was explaining, from decades of experience from Microsoft. AI is also in the back there. We receive, I don't remember how many
billion. So what happens is when we get an alert from a device or from a service, a VM, when we know an event is happening, we bring it all to the cloud, and based on a bunch of information in the cloud, for example, threat intelligence, known patterns, and so on, we can actually analyze it, run some machine learning on top of it, and come back and say, this is what we think is happening. And not just that, we also give you a mitigation. If this thing is happening, from our experience, we know you need to do this so that you can actually get out of that bad state.
Yeah. So, typically here, I'm in the recommendation panel for these various, subscriptions I'm monitoring. Here I can see a recommendation for multi-factor authentication to be enabled for user accounts. It's like, hey guys, you have some accounts that don't have that enabled. This is a big no-no. You should go and fix that. And you have a set of these other recommendations that are down there. And then you have the alerts view as well. So this is the IT view. But now if I want to focus more on the developer, on the OT side of things, I have an IoT application that uses a subset of these resources around IoT Hub and an application itself. So here I can already see, I see 4 IoT Hubs that are monitored, but let me switch to one of them. In my IoT Hub here, which is called Ignite Demo IoT Hub, I have a security section, and I onboarded my IoT Hub into Security Center. You're just pressing overview, and then you have it onboard onto Security Center. And here I see the same type of view, but filtered to my IoT scenario. I have a set of resources that are actually paired with IoT Hub. This IoT Hub might have some other resources behind it, and you'll be able to monitor not just IoT Hub and the devices, but also the resources that are connected to it. Well, in that case, I just have this one, my bad. But you could actually add and say, I have a Stream Analytics job, I have a function, I have a web app. This is my IoT app, and I want to monitor that at once, right? The recommendations, same as the IT view, but once again, dedicated to the IoT scenario. In there, I'll be able to see things that are specific to my devices. And we have an agent for now in C for Linux and Windows devices, but we're extending that in the next few months with other types of languages and other types of device support. But you have an agent that you will install on the device itself for it to report to Security Center through IoT Hub for its health. Right? So that means that you have this little daemon, this little agent running on a device that will make sure that these devices are secure, because the one big threat for an IT application is the device itself. And they have a very cool demo on the IoT booth for doing a brute force attack and so on. I'm going to show you a light version of that demo. Here, I can see a set of, so these are the recommendations. You can see the type. Hey, you need to install the IoT security agent on these various devices. But then you can see see, hey, this device has open ports. No, don't open your ports unless you know what you're doing, right? So you have this recommendation there. The OS here has some issues as well. There's some permissive firewall policies that actually recommend to go and change. Let me switch to the security alerts view for that IoT hub. And in there, if no one played with my demo, there should be nothing. If there is something, I'm going to just dismiss them, and then I'm going to recreate these alerts. So no data to display. Here we go. So I'm actually about to log in into a VM that happens to be connected to my IoT hub. So I'm doing an SSH. I hope I remember the password. Yeah, should be good. If I don't know the password, or I don't know how to type, that's more of that, right? So I logged in. If I didn't know the password, I would try a brute force attack. You know, these IoT devices like Wi-Fi gateway that have the root admin password. Think you've heard about that? Yeah, right.
And then the use of that problem for Mirai for taking down the internet. Sometime we should talk about that as well.
So what I'm going to do is I'm going to add Arjman as a user on that device. First step, right? A hacker would actually go through several steps. Eventually, what I'm going to do as well is I'm going to try and see if I can connect to that malicious website here, right? So I ping that website, see what happened. And then eventually, what I can do is I want to do some crypto mining, some crypto coin mining. And so I'm going to download an app from a GitHub repo, and I'm going to put that somewhere into the device, and then I'm going to execute that, right? So I just did all of that, and let me refresh the alerts view on Security Center for IoT, and hopefully we're going to see these alerts popping up here, indicating that someone logged in into the device, that someone tried to access that IP address, created Arjman as the user, which is a big no, don't do that, and then eventually bring your cryptocurrency miner. So it's loading the alerts, it's going to come, and everything's going to be like, yay, oh, look at that. So someone actually has been also playing on the side, doing a brute force attempt on another device in the area. I told them not to run the demo on the booth, but anyways, you see these new alerts, the suspicious IP address, actually that I tried to access to from that VMA, which is my device that I'm connected to here, you can see. So this is really my device that created that alert just now, as well as the other ones down there, right? So you can see here how, straightforward it is to monitor my IoT application end-to-end security, its posture, fix things based on recommendations from Security Center, and also monitor the alerts on these devices.
And also this whole thing about what an attack looks like is evolving as we speak, right? New attacks are happening, we are learning about those, we are updating how the algorithms which actually detect those attacks, and based on that, you are getting the advantage of that evolution, of the new attacks that we come to know about. So this essentially protects you today, but also is safeguarding you from any future attack that might happen, which we can detect and then come back and tell you.
Okay. So next step is edge intelligence, and we have 2 demos for that. So I think we're right on time,
I think
right?
we're on time, yeah.
It's still 17 minutes. You're going to have time for questions.
Yeah.
So here, what you're looking at is a NVIDIA Jetson Nano. This is a $99 device that NVIDIA is creating. It has a GPU in there, runs Ubuntu, and we run Azure IoT Edge on it, and we deployed some very interesting vision models to detect objects on video feeds, right? And here I have the view of what's happening on the device. Down here, this is what's going on the device. I have 8 video feeds that are actually coming. I don't know what, it's a bit stuttering. I'm using a system actually to extract the video from the device. It's not super efficient. These videos are 30 frames per second, and they're being analyzed on that tiny device here in real time. There's no back and forth to the cloud. We're bringing the AI models onto that IoT Edge device. We can talk more about that on the IoT boost later on if you want to. What I want to bring up is not just the beauty of the fact you can run these workloads on the edge, but it's the fact that you can manage this IoT gateway using IoT Central or IoT Hub directly if you want to. In IoT Central, you can now not just ingest the telemetry data from the IoT Edge devices, but also manage these devices. And so this device that is connected to my application what I can do is I can visualize its health in terms of what modules it's running. What are the various entities, the modules? One is about AI, the other one is about the deep stream things. And you have the various modules. Someone actually brilliant has been developing that part of the demo for me. And so you have these different modules that will extract the frames from the video streams, that will implement AI vision on them, based on the model that's been injected, which is called Deep Stream, and that's the one from NVIDIA, plus leveraging OpenCV and other libraries like that. But everything has been containerized into a Docker container, configured for running on IoT Edge, and from IoT Central, you're able to configure that device and say, I want to run that module, that module, that module on that device here, right? And so that means I can totally work with that device down there. And what I can do as well is I can configure, whatever it's going on in there. So in that device, I can change the video streams that is actually grabbing the data from. So let me actually switch that IP address here, try and make my life simpler by having similar type of addresses. And the device itself will reconfigure by stopping that module that does the analytics and restarting it, and we'll have one of the feeds changed to another video stream automatically. I did the configuration in the cloud. No need to get into the device, SSH, change the configuration in a hard way. No need either to create your own app to manage your IoT Edge devices. Everything happens in IoT Central. While the thing is rebooting, I want to actually bring up the UI here, because monitoring what's going on the Edge device is really important, because what you're interested in is not the frames that are coming, right? This is what's happening on the device down there. What's interesting is to monitor the detection counts, the results of what has been implemented on that IoT Edge device. And in IoT Central here, I can see that I've been detecting a certain number of objects of a specific type. I think it's the person type that is configured here. I could change that as well to detect cars or to count cars. But here, I've been able to detect persons and to get all that data into my IoT application. And eventually, from here, I can trigger an action. I can say, hey, we detected 10 people, maybe, and imagine that being, let's say, in a retail place, when you can now monitor the flow of the customers between the aisles, and you can see they're coming to the register all together. So you can actually trigger an alert to the store manager and tell him, hey, we have like a dozen people coming all together to the register. You'd better have like 2 or 3 of them open now. Right? Not tomorrow, now. And so without having the images going outside of the store, they're analyzed on that edge device in the store. They're not even like recorded or stored on that device. It's real-time analytics on the stream of data, on the stream of frames. And then you can really implement very smart systems that are monitored and managed by the cloud, and from the cloud. So here you can see that it's loading the images. And I think this is my application that gets the video stream that actually has a problem. But you can see that it is rebooting and it's going to get its new video streams in a second. So this is really, what's going on with IoT Edge or the intelligence at the edge, and how easy we make it to manage these IoT Edge devices, especially if you're not a Docker expert. If you want to change the functionality of an IoT Edge device, well, someone will build that IoT Edge device for you, will deliver that to you, they will have the runtime in there. You will hook it up using the same provisioning system as the devices into IoT Edge for that runtime to authenticate to the IoT Central application and then manage that from there, right? So pretty straightforward and pretty interesting way of managing your devices. Let's go back into security. There's a very interesting aspect of security with edge devices, right?
Yeah, so the IoT Edge, of course, as Olivier pointed out, allows you to move workloads from the cloud onto these edge devices, which essentially are gateway class devices which are with a rich operating system. So while you do that, and when I said move workloads, obviously you have to think about the security of those workloads, right? When I say there's a Docker container sitting in the cloud and it's coming down, we do all the signature testing and so on. So we know that the workload running here is actually the workload that started off from the cloud to come here. But more than that, once that workload is deployed, it's still in the user space and the device is still sitting out there. So for some of our customers, they came back and said, you know what, somebody can still go in and steal my IP that intellectual property which I developed over years and years and can take that and do something with it. For which we went back to the drawing board and we started thinking about what if we could move that core IP to the secure part of the system, secure part of the hardware, which is the enclave. In Intel's case, it is SGX. In ARM's case, it is trust zones. And what if we could move that in there, but at the same time make it easy to move it there? At the same time making it easy to attest it as well as to move it into the enclave. And for that we have an open enclave SDK which allows you to wrap your workload and do it once only for Intel and ARM. You don't have to do it twice. And then no matter what device you have, using IoT Edge you can move those workloads into the enclave. And now with that your executable is in a secure part of the system. Usually they are tamper proof. So anybody even trying to put a probe to it, that system would reset and anything in there would be lost. So it gives you an advanced level of security. And we have a little demo for that, and Olivier is going to show us.
So the demo is using that TrustBox.
So TrustBox is from Scaleless. It's our partner who actually have worked with us. This device actually, the TrustBox, won the CES award for most trusted device. You can look it up. So this is TrustBox for Scaleless, our partner here, and we have been doing a lot of work on using the enclave-based security here.
Awesome. So let me switch back to my screen here. Oh, you see the previous demo, loaded the video streams, and that one changed based on my new configuration. And I'm detecting person here on the sidewalk, person here as well, cars, right? So yeah, that's pretty cool. So here we are again in IoT Central. And that demo is interesting because it actually is really hard to put together in terms of, it's very interesting to see how Open Enclave SDK is running under the hood and so on. And to find a way to demo that is hard because things are happening in a very secure environment. And so you cannot put a trace that shows what's going on there. It's kind of hard. So anyways, what we have here is an IoT Edge device running on that TrustBox. So IoT Edge runtime under the hood, under the OS, is the Open Enclave SDK has been installed. That one actually abstracts the type of hardware for confidential compute that is installed in that hardware. The IoT Edge module can now access that confidential compute hardware infrastructure with a simple API which is provided by the Open Enclave SDK. Does that make sense?
Yep.
Okay. And here in the demo, what we're doing is we're going to send to this module an image, whether it's the image sample number 0 or 1 or 2. And we will ask this little algorithm that is running in that enclave to analyze that image and to determine what kind of number is it. Is it a 2, a 0, or a 9, right? And you can see it's not like straightforward and not, something that it's something that we spend a lot of time developing the IP for that little sample, right?
And also the enclave typically on these devices are very small because it's expensive to make those. It's also secured, so there's a lot of technology around it. So they are small. So you have to be very careful what you package using Open Enclave SDK and then putting it into the enclave.
So I just sent the request for the sample number 2, which was a 9, ugly 9. Sent it, and I had a response almost automatically from the little algorithm that is running on that secure enclave of number 9. So it's pretty interesting. So yes, the demo is not like, wow. But imagine that this algorithm that analyzes the image is running on that very secure enclave under the hoods. We don't like to fake things, so we do real stuff. So that's why we have the device. This was powered by IoT Edge as well, and you can see here my secure enclave device with the various module it's running, and they're running on the device, and one of them is the little guy that actually is interacting with the Open Enclave, right? So I had fun, at least, with all these demos.
And by the way, I was on the Edge with 12 demos. They all worked, so let's give Olivia
Thank you. Thank you, guys.
Great.
So Before we jump into some of the questions, if you want to actually see the sessions we had on demand, the breakout sessions, I think we had the last breakout session of the week for IoT. So these are the main IoT breakout sessions. Look into the Ignite website. We had tons of other sessions in the theaters and so on that have been recorded, and some of them are already available on demand. So if you want to actually stay in touch, there is now a technical blog for IoT. It's aka.ms/IoT blog, where you can follow the latest news and so on. It's in addition to the azure.com blog, where we're going to have IoT announcements. This one is more for, hey, I created that cool project, or here, we solved that problem for that customer. Here's how we did that. We also have the IoT show, which is a short video set of shows, as long as some deep dive real sessions that we're running for IoT topics. So subscribe to the IoT show. If you're a YouTube guy, you have the IoT show on YouTube as well. Last but not least, you can reach out on Twitter for myself, and then I can eventually route you to other people within Microsoft if you have specific questions for us. Don't forget to fill in the evaluation, right? And have a fantastic Ignite. Hopefully I see you tonight at the party riding some of the Harry Potter rides or something. I hope you had a great day. I hope you loved the session. Happy end of Ignite, guys. Thank you.
Thank you very much.